This is the video for example 17. We're looking at concentration this time in moles per litre, otherwise known as molarity. And we've got a few problems here to do with molarity. The first one says 15 moles of ethanol dissolved in 90 litres of water. But before we look at the actual problem, we've got to think about, well, what's this molarity again? Let's review what molarity is. First of all, for these questions, we've got to know what the molarity formula is. And that is concentration in molarity, or moles per litre, is number of moles divided by the volume, which you can also write as number of moles equals concentrations times volume, or volume equals number of moles divided by concentration. In order, it's the two rearrangements of that same formula. Wherever we write C, we mean concentration or molarity in moles per litre. N stands for number of moles of solute, and V is the volume of the solution in litres. Don't forget, you've always got to use litres in these particular calculations. We often assume in these questions that the volume of solution is just equal to the volume of solvent when we're doing the V for volume here. Now we can look at question I, number A. So we've been told the moles of ethanol and the volume of solution. So we've got 15 moles of ethanol. The volume of solution is 90 litres. Once again, in these sort of questions, in molarity questions, we usually assume the solution volume is the solvent volume. So now we can just put concentration, number of moles divided by the volume, which is 15 divided by 90, which gives us 0.167. Looking here, two significant figures, only one significant figure there. Our final answer has to be one significant figure, which is just 0.2 moles per litre. Looking at B, now we've got 2 by 10 to the minus 5 moles of strontium nitrate dissolved in 40 mils of water. So we've been told the moles of strontium nitrate and the volume, which is 2 by 10 to the minus 5 moles of strontium nitrate, and the volume solution is 40 mils. But like all good chemists, we've got to use our volumes in litres, so let's convert that. Once again, we can convert by replacing the m for milli with what it means, which is just 10 to the minus 3. So that equals 40 times 10 to the minus 3, or in scientific notation, 4.0 by 10 to the minus 2, or in normal notation, just 0.04 litres. So now we can find the concentration. Concentration equals number of moles divided by the volume, which is just that 2 by 10 to the minus 5 divided by that 0.04 litres, gives us 5 by 10 to the minus 4 moles per litre, and that is to one significant figure, just like our numbers here are to one significant figure. Looking at C, we've got 15 grams of magnesium this time. So we've got the mass of magnesium chloride, and we've got the volume of solution. So that mass of magnesium chloride is 15 grams. The volume of solution is 1.8 litres, and we're trying to find the concentration of the solution, which is concentration equals number of moles divided by volume. Hit a little bit of a snag here though. We've got the volume, we don't have number of moles, so we don't know N, but we do know the mass. We need a way of connecting this mass to the number of moles, and we do have a way of doing that, and that is the number of moles equals mass of a molar mass. So we can convert this mass of magnesium chloride into moles of magnesium chloride if we know the molar mass. We can calculate the molar mass from the periodic table. First of all though, got to figure out the formula of magnesium chloride. We've got to use the cross method for that, which is MgCl2. We can now figure out the molar mass of magnesium chloride. 24.31 plus 2 lots of 35.45 for chlorine gives us 95.21. Now we can find the number of moles equals that 15 grams divided by 95.21. That gives us 0.158, lots of decimal places, moles. I've saved that as A in my calculator because that's going to be handy for me in the future. Now I can say the concentration of magnesium chloride is going to be A, which is number of moles, divided by 1.8, which is the volume, which will now give me 0.0875 moles per litre. Looking here, two significant figures in 15 grams, two significant figures in 1.8 litres. That's got to come to two significant figures, so it's 0.088 moles per litre to two significant figures. I'm moving along to question number 2. This time it says calculate the volume of a 0.75 mole per litre solution required to obtain 3 moles of sodium hydroxide. So this time they've given us the concentration and the number of moles, which is 0.75 and 3 respectively, and we've got to find the volume of solution. Now we know concentration equals number of moles divided by the volume, which also means the volume equals number of moles divided by the concentration. Now we can substitute, that's just 3 moles divided by the 0.75 moles per litre. So to get that 3 moles, we need 4 litres to one significant figure. On to the last question here, which is number 3. Calculate the mass of lithium hydroxide in 5 litres of a 2.5 mole per litre solution. Well, lithium hydroxide, the very first thing, what is the formula for lithium hydroxide? And then we've got to figure out the mass, the volume, and the concentration. So let's see how that is. Lithium hydroxide, they're both just valency of 1, so it's LaOH. We're trying to find the mass lithium hydroxide. We've been told the volume of solution is 5 litres. We've got the concentration of lithium hydroxide, which is 2.5 moles per litre. So what are we going to do? We need an equation now that links mass to this volume and concentration somehow. So we know that mass equals number of moles times molar mass. So we can find the molar mass, which is just 6.941 plus 16 plus 1.08. So we've got a whole lot of data now. We now know the volume. we've got the concentration, and we've got the molar mass. What are we going to do with that? Well, the whole idea is to find the connection between here, we need number of moles. We need to know how many moles of lithium hydroxide we're looking at. And number of moles is just concentration times volume. We know the concentration, we know the volume. We can now find how many moles of lithium hydroxide there are in that 5 litres of 2.5 mole per litre solution, which is 12.5 moles. And now I can convert to mass, because mass equals number of moles times molar mass. I've got the molar mass, I've now got the moles, just got to substitute them in. The mass of lithium hydroxide in 5 litres of a 2.5 mole per litre solution is 299.36 grams. However, looking at the numbers here, 1 significant figure, 2 significant figures, I've got to round that to 1 significant figure, so that's 300 grams to 1 significant figure.